Welcome to the last chapter for the Introduction to Networking. This is chapter 11, It's a Network. And part of this is we are discussing small and medium and large networks, do we create them, how they grow. We're going to talk about keeping the network safe. We're going to talk about things like performance, basic iOS for configuring and exploring files, as well as ending with integrated routing services. We're going to be looking at some of the commands for checking performance, for establishing connections. We're going to be looking at a few of the basic show commands for our devices. We're going to be talking about how small and medium and large networks may differ. Maybe talk about the services that are on each of the networks. We're going to be looking at basic host and iOS commands to acquire information. We're going to be looking at explaining the file system, the structure on a router and a switch, as well as applying the commands to backup and restore an iOS configuration. So let's go ahead and talk about how networks are created and how they grow. So a typical small network is probably going to be a few hosts connected to some type of combo LAN/router device. So when we're picking out devices for our small network, what are some of the considerations? Normally cost, port, speeds, manageability, those are the big ones. I know we also say that expandability and how modular they are is a factor, but when we're dealing with small networks, normally if they're going to be modular, they're not going to be that cheap. So cost kind of dictates if we're going to deal with more modular type items. So IP addressing for small networks. These are schemes that are going to be planned and documented. We're going to lay out a logical plan so we know what addresses are going where, what's going to be a part of the DHCP, maybe servers and peripherals like printers. Uh, do we have any considerations for what host will be able to access internal and external resources? What about the devices themselves? Are they going to be having IP addresses? If we have a single switch in our environment, are we assigning that an IP address? So we do this so that first of all it's documented. That way, if we are, which is a current administrator, we could help track down issues. But if we leave, future administrators should be able to take our documentation and that will allow them to troubleshoot as well. Also, we can filter control based off of IPs if we know them. In a small network, while normally we want heavy redundancy, because redundancy helps to eliminate single points of failures, while they also improve reliability. Normally, with the cost issue, we're not dealing with redundancy. Realistically, we'll probably have one router, one switch, one ISP, and it's just that's what's cheap. So, uh, network considerations are going to be services. That's going to be are we using voice? Are we using SMTP? Also, are we having to do any type of quality of service or prioritizing of network traffic? For example, if we're doing voice in our small network, maybe we want to have voice as a higher priority. If we're looking at web pages or FTP, we may put that lower on the list. So we have to understand what resources are there so that we can better prioritize the network traffic depending on our needs. Common applications could be either network aware applications or application layer services. Application layer services are programs that interface with the network that help prepare the data for transfer. And that's versus network aware application, that's software programs that are used to communicate over the network. QuickBooks Server and QuickBooks Client. Accounting software is very common. That's going to be network aware because you're going to have the QuickBooks Server that will be hosting the QuickBooks file. And so the different programs are going to be communicating over the network. as opposed to maybe Nagios. Nagios is a monitoring program. That may be an application layer service because that's a program that's going to interface with the network as well as either help repair it or monitor it, the data for whatever it's needing. Because the application layer services, the big thing here is prepping. It's not always prepping for data transfer, it's mainly just prepping the network. But if we're looking at specifically prepping the data for transfer, that could be application-based protocols, HTTP, HTTPS, FTP, FTPS, or secure FTP, things of that nature. Other common protocols and other common services could be things like DNS or Telnet or email, DHCP, web, FTP, secure FTP. These are all common network protocols or network services that aid in the communication of our network. Email could be both an SMTP slash POP or IMAP server. Some of these may be combined. Some of these may be put on the router. Just kind of depends on the overall network. If we are looking at applications for our small network, if we're talking real time, things like anything dealing with voice or video, VoIP or video conferencing, these are going to need a higher priority. So that means the infrastructure is going to have to be there, first of all. Second, would be looking at the prioritizing of these applications over everyone else because, again, these have a real-time component. So the scaling or the scalability of a small network really is based off of things like its budget, its devices that are currently in use, and again, the budget to buy new devices, as well as the documentation for both the physical and logical topologies. Because again, this is going to be the basis for how we plan our growth. Traffic analysis is a big one, which is actually not done very often. The traffic analysis specifically helps to deal with, can our infrastructure actually handle new growth? If we're already utilizing 99% of our capacity, if we try to roll out a new service, it may not work. So protocols could be things like Wireshark, seeing what protocols are there. Could be the utilization of our links. That way we could see where the traffic is coming from. All right, now let's think about host-based. If we are looking at evolving protocol requirements, we could start seeing things like what host resources are being used by what applications, what resources are they using, things of that nature. For whatever reason, this slide wants to talk about snapshots of application utilization, and that's going to be trying to get a baseline of understanding what resources are going to be used by our users. All right, moving on, keeping the network safe. That's things like protecting information from data theft, maybe protecting it from data loss or manipulation, so integrity. Identity theft is always a big one, not just so much information theft, but the actual identity information being stolen. Lastly, some type of disruption of service, whether it be a denial of service, distributed denial of service, or other disruptions that may make whatever resources we need unavailable. So here we're dealing with the unavailability of certain key resources. Information theft, identity theft is confidentiality. So here you'll notice very common, we just talked about confidentiality, integrity, and availability. So when you start learning about security basics, you will start recognizing the CIA triad, confidentiality, integrity, and accessibility. And here we actually covered all three. We also have to talk about things like physical security. This is always a big one. Hardware threats. Can you steal the device? Can you just pull the cables out of the wall and run away with it? Environmental threats. Is it too humid? Is it too hot? Is it too cold? Electrical threats. Do we have enough power? Uh, do we have the proper grounding? If we are looking at a heavy thunderstorm, do we have surge protectors? Maintenance. That's always a big one. Uh, Discharge from electrical components, maybe spare parts, uh, poor cabling, poor labeling, poor cleaning, poor just general maintenance. When is the last time the PC was scanned with an antivirus? When is the last time the PC was thoroughly cleaned with compressed air? Since we're talking physical, maybe the software's not a good one, but the cleaning of the air is a big one because, again, at least where I live, the cleaning is huge because in the summer we get 120 degrees days. So if by cleaning out the PCs in the springtime, we actually proper maintenance so that they're able to last throughout the summer without overheating. Other types of vulnerabilities for security, they can be classified into technology, maybe configuration or configuration errors, could be software. Uh, the software may be coded incorrectly. Uh, Maybe we have policies, whether they be access policies, acceptable use policies, security policies, just general procedures and policies that may protect our organization. If we're talking operational policies, maybe we could be talking about a operating system weakness. The nice thing here is there are plenty of detailed information that's outlined. The CERT organization team, the Computer Emergency Response team, actually helps outline vulnerabilities for common operating systems. But the nice thing is we also have to contend with things like viruses and trojans and worms. That's pretty common, so you guys can read them. But common threat now is also things like ransomware, crypto viruses. Now more than ever, backups are becoming more and more important. A reconnaissance attack. So this is always a big one. Essentially, reconnaissance is doing reconnaissance, seeing what's normal, seeing how your network is laid out. And they can do this with things like port scanning or ping sweeps or things like just sniffing packets. That way they can slowly collect information on your network. We also have things like access attacks, maybe trying to break passwords, maybe trying to uh, break hashes or capture hashes so that they could be passed. That's going to be mainly what a sniffer is going to be used for. But you have things that can like break passwords, whether that be through brute force or through common guessing. Plenty of options that are out there for password bypassing. Other forms of access attacks could be things like compromising a host and using that compromised host to do damage. Or you could also do things like port redirection. That is another common type of trust exploitation. For example, we trust port 80 if we're a web server. Well, we could start interjecting other traffic on port 80 because we know that we're going to trust port 80. Other things could be things like denial of services or distributed denial of services. That's where we cause resource overload. We could do that by large packets, by uh, malforming packets, by opening several TCP sessions with a in device. It could also be done distributedly, like if we have 1,000 plus PCs all doing it at the same time. So let's talk about mitigating these concerns. The big one is backups. Backups are really important when it comes to things like protecting yourself from cryptoviruses, from ransomware. Upgrade and update your software. Make sure that you're running the most current software. As manufacturers find issues with their software, they're normally patching them. That way they can fix these holes. We have a AAA service, which is authentication, authorization, accountability, also known as AAA. Authentication verifies you are who you say you are. Authorization basically says you do have access to this resource, and accounting is documenting it. If you access the resource and it verifies that you are you, did you successfully access the resource you needed? Yes or no? That's what accounting is documenting. We could also have things like firewalls. Firewalls could be built in, they could be network based, an appliance, a item on the network, or it could be software. It could be on a host or host based. Firewalls basically look at information coming in and going out and either allow them or deny them access depending on certain criteria. We could do this based off of packet filtering, where they're looking at the packet. We could be looking at deep packet inspection, DPI, where it looks really deep into the packet to verify the information. Could be based off of application or by ports. It could also be done via domain names or URLs. It could also be done statefully or stateful packet inspection. Basically, any incoming packet, if it didn't have a legitimate response to a request from an internal host, it's denied. Basically, that means if an internal host didn't request it, it's not being allowed back in. And the firewall will know what requests were made on the egress. So any ingress will check what egressed to verify that an internal resource actually requested it. Next, we have to talk about things like endpoint security. Security on our devices, our computers, our tablets, our phones, our printers. Because these are actually mobile, we have to have really good security on them. That includes things like our policies. Policies could also include things like running an up-to-date antivirus, scheduled scans, even for our phones, running antivirus software on our phones and a set time for scanning them. Another common policy is a wipe policy, meaning if your device gets stolen, how do they wipe the device? And do they have a way to wipe the device? So let's talk about how do we secure our devices. First of all, change default passwords. Probably put your own password in your device. Any unnecessary services or things that you're not using, turn off or get rid of. And again, keep it up to date. Things like passwords. We're not talking small passwords that are easy to guess. We're not talking words, because a lot of these are able to be broken. You want a strong password, normally 8 characters or more, first. Second, you want 3 of the 4 characteristics of a password. And the characteristics are uppercase, lowercase, numbers, and special characters. Normally you want 3 of the 4 so that you can have a nice mix and match. Alright, so granted, Blue Leaf 23, that does meet a strong complex password. But you'll notice that it is 2 words, blue leaf. So that's very common for a dictionary attack to put together common words. So let's talk about how do we secure our devices like our routers and switches. Here normally we're talking service password encryption that will force our password to be encrypted. If we actually want to set a minimum character length, we could do the security password min-length. We could put on things that may block password attempts after X amount of password guesses within a time frame. We could do things like exec timeouts. That way, if we're idle on the command line for X amount of time, it will actually then log us off or kick us out. We could also talk about things like enabling SSH. That way, we're not using just straight telnet. We could be doing something more secure. All right, moving past that, let's talk about network performance. So, when we go to ping something, normally we're looking at 3 responses: exclamation mark, a period, and a U. U normally means unreachable, period means timeout, and exclamation mark means it actually did it, it received it. If we are on a router and we just type ping, if we don't type anything else, it will actually allow us to continue out the rest of our config by prompting us with some questions. We can actually fill in these portions so that we could figure out what exactly we want to do. Things like maybe we want more than a 5 count. So we could do ping, put in the protocol, put in the destination, repeat count. Maybe we want it to go 10 times, so we'd do 10 there. Maybe we want to change the datagram size to a larger packet. We could do that as well. Or we could just do a traditional ping, and the IP address, and that will ping just with the default, which is normally 4 echo responses. In a terminal, we can always do a stop command. If we're doing a command line on a Windows PC, we could always do Control-C. That will stop our ping. If we want to save it, we should be able to capture the text and save it as a text document or a Word document. So interpreting traceroute. Traceroute actually takes the hops, basically the layer 3 devices between our source and destination. Common show commands that you should be aware of are things like show run, show interface, show ARP, show IP route, show protocol, show version. Show run helps us look at the running configuration. Show interface will give us a detailed interface. Show ARP should show us the ARP table. Show IP route will show us the routing table. Shows protocol will show us the protocols. Show version will give us the version. So let's look at a show version command. This will give us things like the iOS version, the bootstrap version, iOS image, CPU, RAM, and the amount of RAM, as well as the configuration register. The show version command in its entirety will give us detailed information about things like how long it's been up, where the file is stored, what the file is called, used memory out of existing memory. We also have things like ipconfig. That's more done on a host, not on our networking devices or our intermediary devices. But ipconfig gives us the IP of our local machine. It could also list things like its subnet and default gateway. If we do an ipconfig all, we may get the additional information that could be a DHCP server, the MAC address, things of that nature. From the command prompt, if we do a ARP-A, we'll see the appropriate ARP table. So let's go ahead and bring up a command prompt. ARP-A. That will give me my MAC address table. Here happens to be all of my multicast addresses. Here are the MAC addresses that I know. You'll notice there's this one right here, because it happens to be in my environment. That's the broadcast IP. And that is a broadcast frame. But it will map our IPs to our MAC addresses. If we do this from a router, instead of doing ARP, we may want to do a show CDP, Cisco Discovery Protocol. If we do neighbors, should show us the appropriate information on our neighbors, assuming they're Cisco devices. Things like its platform. Is it a router? Is it a switch? If it's a router, what type of router? If it's a switch, what type of switch? If we do show CDP neighbors detail, it should also give us things like its IP address, its interfaces, its uptime, things like that. The show IP interface command, it will give us our interfaces. A better command might be show IP interface brief. This will give us a brief command that will list just our interfaces, our IPv4 addresses, if they're okay, their status and protocol. If the status is up, is it down? Is it administratively down? Is the protocol up or down? This will all be done from a show IP interface brief. This is the best quick command to see what interfaces are operating. If they're up, if they're down, if they have a configured IP address, yes or no. One of our last chapters is managing iOS configuration files. Essentially, what's the structure of our routers and our switches? If you do a show file system, you should be able to see all of the files in memory, as well as what access we have. Do we have read and write, read only, things like that. Here, the asterisks will indicate the current default file system. You'll notice our asterisk is here, which happens to be our flash 0. So our flash memory happens to be where our current default file system is located. If we do show file system, this should be, again, very similar, but this is done on a Cisco switch instead of a router. But again, you're going to show the default storage device. You're going to show the permissions, read write, read only. And again, you're going to see available size versus free. Like with anything, we need to do backups of both our configs and of our software. It all goes back to documentation. If we want to back up everything, we could do this via TFTP or trivial FTP. That way we can back up not just the running configuration or the saved configuration, but we can back up things such as the iOS of our device. How do we set up TFTP? We do a copy startup config space TFTP. That's assuming we have a TFTP server that's available. Newer routers do come with USB ports, so we can copy to USB ports as long as the USB is formatted as FAT16. And how do we copy things to our USB port? We could do copy running config USB flash 0 : /. If we're looking at how to do it, that would prep it for us. Last chapter is our integrated routed services. That's taking our small office and combining our resources, our routers, our switches, our wireless access points into a single device. It's a router, it's a switch, it's an access point. It's all of them in one. They should have wireless capability, things to set up both the wireless mode, things that will allow us to configure the SSID of our Wi-Fi as well as our channel. This is pretty straightforward stuff if you've ever set up a wireless router, but this is going to be for a small home office or SOHO type router. General security principles: change the defaults. Use WPA, do not use WEP. WPA is still crackable. It just takes a little bit longer. Realistically, we're talking an hour or so versus several seconds. The whole disable SSID and MAC filtering, that's subjective. Uh, disabling SSIDs, you can still find the appropriate SSIDs depending on the hardware and the tools that you have. So to configure our Linksys router, normally we plug our host PC into a switch port on the router. We should be able to grab an IP address automatically, or we can check our command prompt to ipconfig to see what the default gateway that was assigned our host is, and we'll use that IP address to log into the router, or we could use what's called dynamic DNS. That's becoming more popular with these SOHO routers. And once we are actually able to log into the router, it will prompt us for our username and password. That is what we want to change. We do not want to leave password as defaults. If we want to set up wireless, we want to go ahead and navigate to the wireless option. Choose the appropriate wireless mode. If you want only N, only B, only G, or mixed, choose the appropriate settings for your environment. Configure the SSID, name the dang thing. Configure the appropriate RF channels. Remember, the wireless channels are 1, 6, and 11, so pick one of those. Normally you want to do a site survey to figure out what channel is the least used in your environment. Lastly, set up the security. Do not use WEP, use WPA or WPA2 for the best security. If you are wanting to configure a wireless client, basically make sure you have a wireless card, browse the appropriate wireless networks, enter the credentials, and if all goes according to plan, you should be able to connect to it without a problem. That's actually the end of this chapter. A quick summary is, again, good design incorporates reliability, scalability, availability. We talked about things like our CIA, confidentiality, integrity, availability. We talked about things like our AAA, authorization, accountability, and authentication. Authentication, authorization, accountability. We talked about things like our ping and our trace route. We talked about ways to back up our configs on our devices, such as our routers and switches. Again, I want to thank you and hope you